Hello, welcome to a quick rendition of the BrickBreaker game. Um, so the idea here is that I've set up a main game file, straight canvas of 500, background of 255, which is white, and I have a ball file here, brick file, and a paddle file. The paddle.pde will be class paddle with float x, y, width, and height. And the paddle will have a constructor where we set defaults. I'll set my width and my height at the top. Width should be maybe 50. Height should be about 10. And this will center my paddle. I also have a show method. It turns out this is all you really need for a paddle. It'll be black and it will be a rectangle. And this is really all that's necessary. So if I want to actually make this, go to my brick game. I say paddle P. I'll build it, construct it, and then I will say p.show, which is the method that I defined here, and then it'll just show my paddle on the screen. It doesn't do anything, it's just a brick. Now, if I want to move it, I can say that the x value is equal to whatever the mouse x value is. So if I move my mouse, my paddle follows. You'll notice there's a little bug on the right side where I can go off the screen. That doesn't really matter here. You can figure out how to fix that for yourself. So we've done a paddle. Now let's do a ball. And the ball's a little more complicated, so we'll have a few more variables. The x value might be width over 2, y is height over 2, so we'll start in the center. In fact, maybe we'll start right above where the paddle is. And say we don't need width and height. That's my bad. We need a radius of 10, 5. And we can say that the Vx is going to be 0 to start. We can actually randomize this. From negative 10 to 10. So in this case, we'll always be shooting upward. These determine our velocity values. and they'll be modifying our positions. Showing the ball is easy. Fill with black. Make an ellipse. With a diameter of 10 and positions X and Y. I'll define a move initially to be X is increased by Vx every move, and Y is increased by Vy. So all this does is define a ball that just moves. If I want to make the ball, I say ball B make it a new ball. Maybe show it first so it appears right there. And we can say that we want to move it. And it just keeps going because we haven't set boundaries. So one thing that we want to say is if the x value plus the radius is greater than the width of the screen, or the x value minus the radius is less than 0, we're going to bounce. We're going to switch our velocity from pointing backward to pointing forward, or vice versa. So this is saying if the right edge of the ball goes off the screen. This is saying if the left edge is. If you have trouble with this, please draw a picture. It does help. Well, for the y values, I really just want to know if it bounces off the top. I don't want to have to worry about bouncing off of the bottom of the screen, because if I pass through the bottom, I lose. And this talks about moving through the bottom. So let's run this. And it works fine. So our move for the ball is pretty good. Now, it'd be great if we could bounce off the paddle. I'm going to do that in just a moment. First, I'll set up my brick. Which is just going to be an x, a y, a width, and a height. Very simple. Set those to some defaults. I'll have my brick be 60 by 30. I'll say that the x value is the width over 2 minus 30, and the y value is equal to the height over 2 minus 15, just to put me in the center of the screen. And all the brick has to do for right now is be shown. I'll fill it with blue, and I'll make a rectangle. So right now nothing happens, and the reason is I haven't made my brick. So let's make the brick. We'll say brick 1 for now. And we'll just show it. And notice it won't interact. Now, the first thing I want to do is build a collision detector in for the pack. I can do that out here. I'll check to see if there's a collision with the paddle and the ball. I'll do that in this file. I'll show you a way to do it in another file in just a moment. I'm going to set some temporary values because they end up being really useful. This is to check if I've collided with the paddle, and if so, I switch my velocity of my ball. So I'm going into the ball and I'm getting dimensions, and I'm saying, where's the top of my ball going to be? It's going to be at the center minus the radius, meaning pointing upward. Same thing with all the other dimensions. Draw it out and make sure this works. I'm going to do the same thing for my left and my right. Where I'm changing instead of x. In this way, I know sort of some dimensions to compare that are in plain English and not math. I'll do the same with my paddle. Because if we can compare with English, suddenly that can make our programming a little bit easier. The top of the paddle is just the paddle wide. The bottom is the paddle y plus the height. The left side is just the paddle x. Paddle x plus the paddle width. The reason for this is that rectangles are drawn from the corner, whereas circles are drawn from the center. So what I can say is, if, well, the easiest way to think about this is, when am I not colliding? So I say, the left side of the ball is to the right of the right side of the paddle, the right side of the ball is to the left of the left side of the paddle. Draw it out and you'll see why this is. Same thing with the top and bottom. So I say, if ball right is greater than or is less than paddle left, or ball left is greater than paddle right, or ball top is greater than or is less than or greater than paddle bottom, or ball bottom is greater than less than paddle top. Now, conceptually, this makes some sense. This means or. So what I end up saying is, in fact, if it's not any of those cases, I know I'm intersecting. So in that case, I should say ball in the Vy direction should equal negative ball Vy. So I just flip the Vy and I do my collision check. This is really all the logic I need to see the paddle collide. Here I need to use that. I say every frame I'll check to see if there's a collision. And it bounces. If you're good at the game. Now you'll notice the brick doesn't do anything yet. There are a couple ideas we need to deal with. The first idea is that, and you should draw this out, if the ball is half over an edge, we know it's intersecting that edge. So if I just draw an ellipse really quickly, of 10, 10, and I fill it with black and draw it over top, and I say this. I run this and you'll see that I have a ball sort of on the edge there. Now this is for demonstration purposes. The whole point here is to see that when the ball is on the top, you can see that the bottom of the ball is below the edge. The top of the ball is above the edge. In that case, we want to bounce up. Likewise, if I do the same thing and I say, oh, well, something like this, well, I have the same idea where the top of the ball is inside and the bottom of the ball is outside. So the if statements that I need to actually make a collision between the ball and the brick happen, consider the fact that half the ball is going to be hanging over the edge of the brick. The way I deal with this is I do something like this. I'll make a method called void check. I pass in a ball. What this says is I'm using this temporary variable called b. It's going to be a ball, and whatever that ball is, I'm going to see if it falls within the range here. We actually call that is I say brick1 dot check, and what am I checking? I'm checking against the ball. Now I can write some logic. So I want these same variables that I had before because they're pretty convenient. And I'll paste them. It'll work just the same because the ball is in fact called B here as well. So I say, I want to check against this ball. And I want to say that if ball B value, or the ball right, let's start with the top. Ball top is above the top edge and ball bottom is below the top edge, and the ball left is between and let's say the ball left is bigger than the paddle left, and the ball right is less than the paddle right? If all of those are the case, then I know I've hit the paddle. In fact, really it's just the center values of the ball because I can hit at the bottom. So if ball X is less than paddle is greater than paddle X, and X is less than paddle X plus paddle width. Oh, not paddle, brick. The whole idea is that I have this big inequality, and it's going to be another sort of if statement. Now, all this requires that I have something called active to determine if the ball is active, or the brick is active. If it is, I want to show it. If it's not, I don't. All bricks start out being active, and I only show them if they're active. If they're not active, I don't show them. This is the same as saying if active is true. Now, if it hits, if the ball hits it, active should turn false. Maybe I add to my score, something like that. So what I can say here is, I only want to check this if the ball is active, or if the brick is active. So what I want to say is if ball top is above Y is greater than or equal to Y, and ball bottom is less than or equal to Y, and ball bottom is greater than or equal to Y, and ball B dot X is less than X of the brick, and B dot X is greater than that. And bounce off the top. Do the same. For the bottom of the brick, which is Y plus H. And then we're going to do the same for the left and right sides. And if the ball Y is within range. And we'll do this again at the right side of the ball, or of the brick. And everything else remains the same. So how do I call this? Well, it's already being called. Okay, so the issue has been fixed. Here's a simple side issue. It's getting late and easy to make mistakes. In general, this is the most complicated part. Not really an easy way around it. You have to draw it out. Once you have that, though, the game essentially works. So what you want to do, you might want to make another brick. Set a new X and Y. Then do a check against the ball, and here we go. And I lose. You can implement a score pretty easily. I'll leave that to you. Have a good night.